Now let's take a look at page 107, the structure question number 29. And the question is pretty long, so let's read it all together. Like it says, braces originally made of pure silver. Like it has take over time and it forms some black sulfur sulfate, like this one, form on the surface. And we want to clean this up. So we use aluminum in the reactions below, and it told us the mass of braces decreased by 0.0128 in the cleaning process. Alright, so it's actually turning from silver sulfite to silver here, right? It says how many moles of sulfur that we have removed from the cleaning process. So what is the decrease by 0.0128, that mass? This mass should be the sulfur that we lost, right? Although aluminum and aluminum sulfate is solid here, but here we only take a look at the process. So it's simply from the mass of, let me change to another color. This one will be mass of silver sulfite, and then minus the mass of silver, then we will have 0.0128 grams, right? Because it's decreased by. So we know that for this one, it should be equals to mass of sulfur, the mass of sulfur that's decreased in this reaction. So now we know the mass of sulfur, and do we know the molar mass of sulfur? This one should be 32.1 gram per mole, right? So the mole will be mass over molar mass. The mass here is 0.0128 grams, and then divided by the molar mass of 32.1 gram per mole. The moles will be 3.988 times 10 to the power negative 4 mole here. So this is the answer. Oh, but this one, since it will be the final answer, then I would only take 3 significant figures here. So it will be 3.99. Remember, always 3 significant figures at the end. Alright, then this will be the answer for part A. And now, let's take a look at the second question. What mass of aluminum was used in the reaction? Alright. So let me copy the balance equation here. And then now let's take a look at if we know the sulfur, the mole of sulfur, let me write here, the mole of sulfur is 3.99 times 10 to the power negative 4, right? Then, do we know the mole for Ag2S? The mole of sulfur should be equals to mole of Ag2S, right? Because we only have one sulfur in Ag2S. So we know that the mole of Ag2S here should be 3.99 times 10 to the power negative 4 mole, right? So now, let's put the mole here. The question is asking about the mass of aluminum, so can we derive the mole of aluminum first? Let's write the mole ratio. The mole ratio should be equals to the coefficient of Ag2S and aluminum, right? So the coefficient here should be 3 to 2. And remember, if we trying to calculate the mole, then it should be putting the unknown at the top, the known at the bottom, and now we times 3.99 times 10 to the power negative 4, right? So the mole here should be 2.6 6 times 10 to, because in the middle, probably I'll take a bit more, so it's 658 times 10 to the power negative 4, right? Now, we have the mole of aluminum. Can we calculate the mass? So if we want to calculate the mass, then we will have to do like calculate the molar mass first, right? What is a molar mass for aluminum? It's written in the question as 107.9 gram per mole, right? And then we have the mole, we have the molar mass. What should be the formula for calculating the mass? Should be equals to mole times molar mass, right? This one should be mass of aluminum. Then we'll use 2.6508 of 658 times 10 to the power negative 4 times 107.9. The answer should be 0.0287 grams, right? If we take 3 significant figures. So this one should be our final answer for part B.